Hey students, welcome back to Instructive Academy. So in the last session we started with the topic the movement of forces and equilibrium. We completed few of the topics from this the main important point. We completed up till the movement of force. Let's start with a new topic today. That is couple. So according to you, what exactly a couple is? So let me just make a explanation of all the topics up till we finished. That is, we finished a translation motion, that is just pushing the object in the same path. And what is rotational motion? We also completed that. That is, if the object is pivoted at a point and a force is applied on the object, then the object starts to rotate in the axis of the pivot point. Okay, that was rotation motion. And in the rotation motion we can also explain the torque and the moment of force. What was torque? The amount of force used to move the object not move, to make the object rotate in its axis is called as the torque on the object. And what was moment of force? The applied force on the object and the distance between the product of the applied force on the object, the magnitude of the applied force on the object, and the distance between the pivot point and the applied force is the moment of force. And the moment of force has two directions, either in anti-clockwise or in clockwise. Okay, either in this way or either this way. Cool. So let's start with, we also discussed, deal with some of the few examples and the units of the moment of force. So in this session, we're going to be dealing what exactly a couple is. So let me explain you with the same example what we were dealing before. We deal with many of the examples where the pivot point was here, where we are applying the force to an object with no pivot point and all. We're just applying this thing. So according to you, if we apply force to two equal and opposite forces at two distinct points, what will happen then? That means if I am applying force from here also and I am applying force from here also, that means in this way, the same amount of force, what we are able to see? We can see that the body starts to rotate at a virtual pivot point. This forces or this system is called as couple. So we understood what exactly a couple is. So let's move on further by writing the important points, that is two equal and forces, first thing, and second is at two different points. Cool. Okay, there are lots of example of couple. We can also find a couple over here in the steering wheel. We grab the steering wheel from here and here, right, with the help of our hands. If you want to take a right turn, what do? We pull this from this side and we push this from this side, right? We exactly do this so that the body starts to rotate because of the equal and opposite forces at two distinct points from the pivot point. Remember, the distance between the two forces from the pivot point must be same, otherwise the couple will not work properly in the system. Okay, the distance, these points. Okay, so also there are very few examples like opening the tap. While opening the tap, it's the same example like staring. So let's move on to the new example, like opening the cap of the bottle. So if you take the example of the opening the cap of the bottle, what we exactly do, we open the cap of the bottle in this way, right? In this way. So what we exactly do, we use a thumb to push the cap from this side, and we hold it from this side and we pull it. So exactly this is how the couple works. Okay, let me draw the diagram so that we'll able to understand and write in exam and explain exam in exam very carefully. So if this is point O, this is the pivot point, and this is point A, and this is point B. If we apply F Newton force at point A, and if we apply F Newton force at point B, and the distance between OB is d meters, and distance between OA is d meters. So what is the moment? Moment of this is F into d, plus of this is F into d. Let's mark this as in a box, and it's a very important question. So move on to the next topic, that is equilibrium. So what is exactly equilibrium? Equilibrium is defined in a very simple way. Let me explain you in a very short manner. That is, if there is a body, if we consider this body, and there is no pivot point. If we consider this body, and we apply force A, force B, force C in this way, and if the motion of the body, that means, let me tell you very clearly, motion means in the direction of the resultant force acting on the body is R, and R is equal to 0, then the body is said to be in equilibrium. Let me explain you once again clearly with an example. Let me take the example of this pencil only. So if we think if I'm applying force from here, right, and we have a pivot point and it will move in this way. So if consider there is no pivot point over here right now. So if we just apply the force to the pencil, it will move in this direction, forward direction. Okay, what if we apply force from here and here? Okay, the same amount of force, it will move in a couple way. So now imagine, students, if we apply force from here and you apply force from here, and I'm applying force from here, what's happening to the pencil? There's nothing going on with the pencil, because the pencil is not moving at all. And that means the resultant force acting, let me make you clear, let me tell you clearly what exactly resultant force is. Resultant force is the direction of the movement of the body due to force applied on it. Is the resultant force is 0, then the body is said to be in equilibrium. That means any of the forces applied on the body will remain unchanged. The body's position remains unchanged. Okay, so let's study. There are different kinds of equilibrium, out of which let's start with the first one, that is static. Static equilibrium. Static equilibrium is if a body's position remains unchanged changed due to external applied forces. Then it's in static equilibrium. You must have understood definitely, because if many of the forces are applied on the body and the body remains the position of the body remains unchanged, then it's in static equilibrium. What's dynamic then? Dynamic equilibrium. Dynamic equilibrium says that if a body X is in a state of motion, translation motion, in a linear motion, and there is no force acting upon the body, though the body remains to be in the state of the same motion, that is translation motion, then the body is said to be in dynamic equilibrium. Cool. The next topic is the principles of the moment, sorry. So, the most important one which we have to understand, that is the summation of all the forces which are there in, let me go to that page so you will understand it more clearly. Let's do this page. Okay. The summation of the forces applied on a body for anti-clockwise must be equal to summation of the forces applied on the body which tends to move in clockwise. That means this rotation will make the body move in the anti-clockwise direction, and imagine if a force applied over here, then it will move the body in clockwise direction. That means the summation of all the forces which makes the body move in anti-clockwise direction, that means this force and this force, must be equal to the summation of all the forces which makes the body move in clockwise direction, that means this force must be equal. Okay, cool. Let's move on to the next point. Let me try it before going to the next point, that summation of all the forces which tends to move the body in clockwise must be equal to summation of all the forces which tends the body to move in anti-clockwise direction. So now, after this, we have done with all the topics. So if you like the video, do share, like, and subscribe to our channel. And after this session, we have completed the chapter 4. Thank you so much everyone for attending our session. Stay tuned with the session, and we'll be continuing with many more topics of this